Hi all, this is day 60 of my GATE CS prep journey. So I thought to record this because I've just this is the question I've done today regarding CN PYQ. This is a PYQ for subnetting concept. So I've studied, I've revised, and it's better to do PYQ simultaneously sometimes. So yeah, I mean, you will revise the concept through question and you will get the feel that you're solving PYQs as well. And you'll learn a lot of things through PYQs. So I've done this. It's little lengthy. It was lengthy because yeah, a lot of concepts are there, like very basic concept included in this question. So um let me show. This is the question. Okay, there is subnet mask of particular network given, and in option uh, you will see pair of IP addresses, and we need to find which pair of address could belong to this network, that is subnet mask. So I hope you got this question. Like, this is a question basically, and these are the options. So I have solved on this paper, and then I've made, what do you call it, summary also. So in question, what they are asking is like a subnet for particular network is given, and from the options of pair of IP address, we need to find which of the following pair of IP address could belong to this network. So this is the question. I think I have already made clear above. So first thing is, starting from very basics, is like what is IP address. So IP address would be like combination of network and host, so which is 32-bit, like total would be of 32 bits, and it's of network and host, and like from and subnet mask tells how many bits belong to network and how many bit belongs to host. So in subnet mask there would be an ID, network ID plus subnet ID and plus host ID also. So network ID is compulsory and it's fixed. Subnet ID is not compulsory, it is extra once after network ID. Then host ID is to identify individual devices within the subnet. So to find which IP address belong to the network, we need to do bitwise AND between given subnet mask and pair of IP address. Why bitwise AND? Cause ANDing gives only network address, because if you know the AND operation, it will give one when both are ones. That AND operation basically, it will cancel out all the zero things. It zeroes out basically host portion, it zeroes out host portion, and since we need to find which network it belongs, so it will give only network ID. That's why bitwise AND we are performing between given subnet mask and IP addresses. And after doing bitwise AND, if we are getting the same network ID, then this network belongs to the IP belongs to the same network, corresponding network of subnet mask. So IP address of 32-bit, like IP address is of complete 32-bit, and it is divided into two parts, network ID and host ID. That's there, but IP address is like basically into four parts. Each part is of 8 bits called as octet. And in subnet mask, like starting are continuous ones and then continuous zeros. So this is given subnet mask from the question, like 255.255.31.0, and like according to concept of subnet mask, continue one should be there at start. But if you see in third octet, these are not contiguous ones, these are mixed match. But since this question is of like very long back, old gate question, so that time it was the concept they used to follow, that not only continuous ones, mixed matches are also allowed. So it's fine because it's a old gate question, and that time it was the concept they were following, so it's allowed here. So if you ever face this kind of subnet mask in question, just understand this is the from old times, not the recent one. So it's fine, there is nothing wrong with it. Just Keep in mind, this is the old concept of subnet mask, not the recent one. And so we have subnet mask, we have a pair of IP address. We can perform bitwise AND, but before performing bitwise AND, you need to see if given subnet mask belongs to IP address. And here there would be there are like two types of addressing: classful and classless. Classless denoted by slash, that is called as CRDR. We'll see in like, not now, but just here it is a classful address we are using. Again, IP address is of 32-bit and divided into 4 parts, each called as octet because of 8 bits in each part. So before performing bitwise AND, you need to see like which class it belongs to, the IP address. So for that we need to remember the 5 classes and their range, IP address range. From that we can see this IP address belongs to which class. So for A it is 1 to 126, B to 128 to 191, 192 to 223, 224, 239 and 240 and 255. This range everyone might have by-hearted by now. I think it's very easy and it's important. You should remember this. Class A. And let's go to check now options. So in options also, like it's a pair of IP address. That means 2 IP address would present. And see, you need to see each octet by octet, like both the octets should be same, then we can perform the bitwise AND. If octets are not same, then there is no point to check. You can just eliminate that option. So first option, if you see, it's like 172. First octet is 172.57.88.62 and second is 172.56.87.23. So if you see second octet itself is not matching, so you can just cancel out this option because octets are not same, so we cannot perform bitwise AND. Okay, but if it would be same octet, then how you are going to do the bitwise AND, then how you are going to see the network ID belongs to same network or not. Bye bye. But if not different, how to check? That's what so first thing you need to check for which class it is belonging from class B range. So this, if you see the IP address, these belongs to class B range, right? 172. See, 1 to 126, 128 to 191, so it falls under class B. And subnet mask for class B, since I have gone through subnet mask concept already, I have revised also. I know how many bits would be there in for class A, B, C. Like class A, it would be 16 network ID, 16 host ID. Class A, 8 network ID and 24 host ID. Then class B, 16 and class C, 24 8. So for class B, 16 should be network ID and 16 should be host ID. So it's right. We can go ahead and perform the bitwise AND between the subnet mask and IP address. So here we are considering here, even though like second octet is different and there is no need to check, but I'm just explaining so that like if it would have been the same octet, then how we are going to do this bitwise AND. So consider like both second octet are same, like 57. What I've taken is 57 you can consider for time being to understand how to perform it. Just different. We need to perform bitwise AND for the third octet because it's different, which is 88 and I mean, of course, IP address and subnet mask, then again IP address and subnet mask. So 88 and 31, because that's the third octet from subnet mask, which is 255.255.31.0. So 88 and 31, 87 and 31. Bitwise AND is, the operation when both ones are there, output would be 1. So 88 and 31. So 24 and 23 are coming, both are different, so it does not belong to same network, so this option gets eliminated. So this is traditional method of performing bitwise AND. So there is short trick of even and odd bit. Okay, so you can see 88 is even number. So for even number in binary, last bit would be 0. And 31 is odd, last bit would be 1. So ANDing between 0 and 1 would be 0. And same way you can see the 87 and 31. 87 is also odd and 31 is odd, so both are odd. And output would be 1. So 1, 0 are different. So it does not belong to the same network. So this option gets cancelled. Let me So this is second option, you can see. Wait a sec, let me see it here. Sorry, here it is. So this is I have explained. Even number when converted to binary, if it is like last bit is, for even it would be 1 last bit in binary, and for even it would be 0, for odd it would be 1. For any binary value to become odd, last bit should be 1, last bit should be 0. So again, so second option you can see 10.35.28.2, 10.35.29.4. so first two octet are same, no need to do bitwise AND there. Just 28 and 29, third octet. 28 is odd. Sorry, 28 is even, so last bit would be 0, and 31 is odd, so 1 and 0 is 0. So here even I have written C. And 29 is odd, 31 is also odd, so 1 and 1 is 1. So both are different, so it does not belong to same network ID. This option also gets cancelled. Now, so again here what they have mentioned is before performing bitwise AND, need to check if subnet mask valid for pair of IP address. We need to find if subnet mask is valid for a given pair of IP address from the class octet range, first octet range. If you see third option, 191.203.31.87 and 191.234.31.88. So yes, second octet is also different, so no need to check ahead, just cancel, eliminate this option. So yeah, I think this option also gets eliminated. Last one only remains. So again, this is like bitwise AND, but even odd concept, not the traditional bitwise ANDing. Third octet only, because both first are same. 129.31. 129 is odd, 31 is also odd, so 1 and 1 would be 1, which is odd, and here 161 and 131 both are odd, so and would be 1 and 1 is 1, odd. So third octet same, can perform bitwise AND. So from this we can see we can perform bitwise AND here. We cannot just conclude like this is the correct option. Since third octet is same, we can perform bitwise AND, then we can see. See here, after performing bitwise, and then it belongs to same network. That's all. That was the trick. Instead of getting, wasting time to do bitwise anding, you can just see even odd concept last bit and then do bitwise and. That was the PYQ I've done for subnetting concept. It was very basic, but a lot of things get covered here. So yes, I studied this. I thought to record and upload it. Hope it helps. If you have any suggestions on this, you can just let me know and tell me how your prep is going on in comment section. Do you feel this is long journey, or do you feel like time is limited for prep? What are your thoughts right now?